Hey everybody, this is the first of 4 short videos going over a couple example problems working with law of sines and law of cosines. These were practice problems that we had assigned on Tuesday and Wednesday, or Wednesday and Thursday, I'm sorry, and hopefully you can go over them with some notes and figure this stuff out. So the first problem says, use the law of sines to solve for all possible triangles that satisfy the given conditions. And they give us 2 sides and an angle. So this is obviously going to be an SSA situation because of side, side, angle. And one of the first things I would want to do is draw this triangle out. Now I don't know specifically what the triangle looks like, but I know it's a triangle, so it's got 3 sides and 3 angles, and I can just randomly draw a triangle. Now when I do that, I can adjust this however I want, but I'm going to go ahead and label the sides. And I'm going to say this is angle A, this is angle B, and this is angle C, which would make this side A, which is 30, this side C, which is 40, and this angle A, which is 37. Now this definitely is not drawn to scale, but at least we can go through and try and figure out some different things. And the first thing that we're going to do is we're going to try and find angle C, because I know side A and angle A, and side C I want to find angle C. So I'm going to say sine of C over little c equals sine of A over little a. Fill in what I know. So sine of C over 40 equals sine of 37 over 30. To simplify this, I'm going to say sine of C equals, I would multiply both sides by 40, and I would get 40 sine 37 over 30. And to get C by itself, I would do the sine inverse. So sine inverse of 40 sine 37 over 30. So I'm just going to take a second, I'm going to plug it in my calculator, and I get 53.4 degrees. So 53.4 degrees. Now one of the other things that we have to check is we have to check about the supplement, because the supplements have the same sine values. And so if I did 180 minus 53.4, I get 126.6. And so I'm going to put that in green. I'm going to say 126.6. So angle C can either be 53.4 or 126.6. Now how do I know if that's possible? Well, if that's the case, let's do the blue triangle first. If this triangle here is this angle is 53.4, how would we figure out this angle? Well, we would do 180 minus 37 minus 53.4, and we would get 180 minus 37 minus 53.4, you get 89.6. So if this is angle C, angle B is 89.6. Now we also have to go through and figure out, will it work if there's a green triangle? Well, again, let's do 180 minus 37 minus 126.6. If I do that, 180 minus 37 minus 126.6, I get 16.4. Since this works, I can go ahead and have 2 triangles. This blue triangle, I would then have to go through and just find side B using law of sines. Oops, wrong color. And the green triangle I could also find using law of sines to find this last side B. And so there's 2 possible triangles in this situation. The reason that happens is because when you do the sine inverse, it only gives you the values in the first quadrant. But if you remember on the unit circle, if 30 degrees has a sine of 1/2, 150 degrees also has a sine of 1/2. So when you do the sine inverse of 1 over 2, well, yeah, 30 degrees is your one option, but so is 150 degrees. And in triangle trigonometry, both of those have a possibility of working. So go through and figure out side B. That should be pretty straightforward. But this is one example of how you go ahead and figure out 2 or 1 triangles for law of sines.